Now we're moving to our next measure. This is closeness. This is how close any one node is on average to everyone else. So this will be calculated for the main component. And as I said, you can calculate this in terms of in. You can calculate, so that would be the closeness in terms of the people sending you ties, or how close you are to them, and out, and all. And all would be used, again, generally in situations where you don't have directionality. So let's do in. Okay. And let's try to make this a data object. All right, it says it made an object. Yes. All right, good. Let's make. I've got a couple eyes here, so that's right. Okay, so if I sort this, all right, I'm getting less variation. So my top in closeness is 9.3, and my bottom is 4.8. So not a whole lot of range in here, which that's probably in part, and we have a less dense network. What that suggests is that there just isn't all that much variation. I would expect more variation if you had a really tight periphery, or I'm sorry, a really tight core, and then lots of little pendants off the periphery. In this case, we don't have this massive core periphery structure. We have a network that's fairly loosely connected. I mean, we do have pendants, but the ties are more uniformly connected than this sort of tight core periphery structure. So it's not totally shocking that we're not getting a tremendous amount of variation in closeness centrality. All right, let's do out just to see, because we can do in terms of both, and because the out degree centrality people are sort of interesting people. So this is in terms of the ties that people are sending out again. My guess is there might actually be a little bit more variation here, but we shall see. Again, we're copying the same trick. We're making it into a data object. We first get the measure out of iGraph, but iGraph is kind of funky and weird, so we then need to make another data object that is a little nicer to work with. When you're doing this, not for pedagogical purposes, it would be okay to leave it as vectors or other data objects and then combine them together at the end. But to give a sense, like one by one, I'm putting these into data frames. Okay. Oh, there's more variation. How shocking. So out degree min 0. Let's look at the top. Whoa. You know, that's not helpful, because let's see something here. So that's an out closeness. You know, you need out closeness, not out degree. Too many outs. There we go. Right. Okay. Let's try this again. There's a little more variation. I knew that was too good to be true. So top is 4. Actually, is there more? Let me compare these. Top is 4, bottom is 3. Let me look at that. Actually, I think that there's less. Yeah, there's our, not in degree. Let me do in closeness. Yeah, there's less variation in out degree. So, well, I suspect, so what does that tell us about the network? There's not a tremendous amount of topological advantage, aka advantage of the way the network is wired in terms of closeness centrality, which means that there's not someone who's uniquely being able to diffuse information and have that all get spread out because they are just closer to everyone else. We're going to visualize this now as a network, but I expect it's not going to be a very interesting network sizing it, I'm sure that the network's interesting, because there just isn't a tremendous amount of variation. I could do things to exaggerate it, as I did with the in degree. I divided it by 5 to scale it down so I could actually see something, and I'll do that a little bit later with betweenness. But I suspect what we're going to see here is that, frankly, people are fairly uniform. And so if I was doing a regression sort of variables approach kind of thing, not a whole lot of variability, probably not a whole lot of predictive power in this measure. Now, as the network changes over time and there begins to be more connections, then there might become more variation in closeness. So particularly if the network begins having a core, like a strong core, and then some kind of periphery structure, then I might expect more variation in closeness, and closeness might become a more important feature in this network. All right, let's zoom and look. And yeah, boring. All kind of little. Probably not the best. This is not the measure that I'd be writing home about in this particular network. But in other situations, this could be helpful, and often is.